Hello students. Today in our video we're going to be looking at chapter 7 and the first section 7.1, which relates exactly to the activity that we did yesterday with the pretzels and the marshmallows on systems of equations. And just to recap, a system of equations, as it says here on the notes page, is two or more linear equations in the same variables. That would be two or more linear equations perhaps on the same graph. And the solution to a system of equations, which is very important for you to know, is an ordered pair that satisfies each equation in the system. So we're looking for one ordered pair that will satisfy every equation that's in the system. Well, let's look at how to write a system of equations first, and we're going to base that on the activity we did yesterday. So I'm going to look at the first problem. At Homestead Heritage Farm, we counted horses and ducks in a fenced area. In all, there were 18 heads and 46 legs. How many horses were in the fenced area? Well, first we need to identify which animal is X and which animal is Y. So I'm going to say that horses is X since it comes first, and that the ducks are Y. And we know that there are 18 of them in all, so a first equation is going to be the number of ducks plus the number of horses equals 18. So we're going to say X plus Y equals 18. And I'm also going to put that in example 1 up here. X plus Y equals 18. And then the second part of that is going to deal with the legs that they have. Well, we know that horses have 4 legs, so we're going to call that 4x. And we know that ducks have 2 legs, so that's going to be plus 2y. And the total legs that they have are 46. So my second equation is 4x plus 2y equals 46. So I'm going to write that up here. 4x plus 2y equals 46. And you remember from yesterday that our solution was 5 and 13. There are 5 horses and 13, so that's going to be my solution. 5, 13 for the number of horses and the number of ducks. And we can plug those in just to make sure. 5 plus 13 does equal 18, and 4 times 5 is 20, and 2 times 13 is 26, and 20 plus 26 equals 46. So we know that is a solution. And let's slide over here to number 2. On what we did yesterday. We have some cats and some birds. Well, we know we're going to use cats is going to be X and birds is going to be Y, just because that's the order they're in. It doesn't really matter. And I know that there are 25 heads, so my first equation is going to deal with the heads. The second one's equation is going to deal with the legs. The first one would be X plus Y equals 25, because that's what the problem says the total heads is. So that's going to be my first equation, X plus Y equals 25. And my second deals with legs. Well, cats have 4 legs, and birds have 2 legs, and we know that there's a total of 84. So that's going to be my second equation. 4x plus 2y equals 84. And from our problem yesterday, you might remember that our solution was 17 cats and 8 birds. So let's plug that in and just check. 17 times 4 would be 68, and then 2 times 8 would be 16, and 68 plus 16 does equal 84. So that is the solution to our system of equations. So the next thing we're going to look at is verifying if a point is actually a solution to a system of equations. So let's say that I'm given the point 4, 1, and I need to know if this actually is a solution to the system of equations. So how would I do that? Exactly. I would plug it into both equations to see if it works. So let's try it. 4 is X and Y is 1, so 4 plus 2 equals 6. Well, it works for that one. So I can put a little check mark. Let's try the other one. 3 times 4 is 12. 12 plus 1 does not equal 11. So that doesn't work. So the answer is no. It is not a solution to this system. So let's look at the second problem over here. We have 4, 3. Let's plug it in. 4 times negative 3 is negative 12. Negative 12 plus 2 times 3 is 6. Negative 12 plus 6 is not negative 18. So that one doesn't work. We'll just try this one. It doesn't really matter. 4 times 6 is 24 minus 3 is not 27, so this one is not a solution either. So neither one of these pairs fit their system. And here's a brain stretcher for you. I'm not going to answer it on the video. We're going to talk about it tomorrow. If I have two lines on the same coordinate plane, what are all my options for what those two lines could do? I'm going to let you think about that and go ahead and write down some answers, and we'll talk about them in class tomorrow. One way that we can find the solution to a system of equations is by graphing both of the equations and then figuring out what point satisfies both. Now I'll go ahead and tell you there are 4 ways that we're going to learn on how to find the solution to a system of equations. So graphing is just one of them. We'll get to some others as we go through the rest of this chapter. So let's talk about graphing. So the solution to the system of equations is the point where the lines intersect. So when I graph these equations, wherever they intersect or cross is the point that's going to satisfy both of them. So let's look at that. I'm going to skip these two and we're going to go over those in just a second. So let's look at example number 1. I have the equation x minus y equals 4 and 4x plus y equals 1. Well, I'm going to graph both of these. The best way for me to graph, and if you want to choose to do it a different way, that's fine, is to put them in slope-intercept form. So the way I'm going to do that is I'm going to move the y to this side to make it positive, which is going to be y equals x minus 4. And I'm going to graph that. I know that my slope is 1 and my y-intercept is negative 4. So I'm going to go down to 1, 2, 3, 4 on the y-intercept. Slope is 1, up 1 over 1, up 1 over 1. And here's where it is imperative that you use a ruler. If you don't use a ruler and your line's crooked, you will never find the solution. So I'm going to use a ruler to draw my line. And then I'm going to use a different color to draw the other one just to make it a little bit more obvious. The next line is 4x plus y equals 1. And to change that to slope-intercept, I'm going to do y equals negative 4x plus 1, because I moved the 4x to the other side to keep y positive. So my y-intercept is 1, and my slope is negative 4. So I go down 1, 2, 3, 4, and to the right 1, and there we go. And I'm going to do one more point, go up 1, 2, 3, 4, and to the left 1. And there's the 3 points on my line. I can draw it with a ruler. And the point where they intersect, ooh, I forgot my arrows. The point where they intersect is the solution. And this point would be 1, comma, negative 3. 1, negative 3. And that is the point where they cross. Now, just for clarification's sake, I'm going to follow this hint down here. You can't see it on the TV, but it's on your paper. We're going to follow this hint, and we're going to plug 1, negative 3 into both equations and see if they work. So let's try that. 1 minus negative 3 minus a negative 3 is plus 3, so 1 plus 3 is 4. It works. 4 times 1 is 4, and 4 plus negative 3 does equal 1, so this is the correct solution. So let's look at example number 2. In example number 2, I have the first equation, y equals negative 2x minus 1. Well, it's already in slope-intercept form, so I'm just going to go ahead and graph it like it is. My y-intercept is negative 1, and my slope is negative 2. So I go down 2 to the right 1, and then I'm going to go down 2 to the right 1, and I'm going to draw my line. And it's important when we're drawing these lines that you draw all the way through the graph. And now I'm going to change colors. And I'm going to put the second equation into slope-intercept form. Y is positive, leave it there, equals negative 2x plus 2. So I'm going to graph it. I go up to 2 for my y-intercept, and then my slope is negative 2. So I'll go down 2 to the right 1, down 2 to the right 1. I've got my 3 points, and I draw my line. What do you notice about those lines? Exactly, they're parallel. And I know that they were parallel because the slopes were the same. And parallel lines never cross, so that means there's no solution. If parallel lines never cross, and you have two parallel lines graphed, then the answer is going to be no solution. What I'd like for you to do for your practice problems is to graph number 3, find the solution, and take a picture of it and send it to me and turn it in using the turn in button in Edmodo.